Hello class, in this lecture I will try to solve some Hawkes learning problems related to chi-square distribution. So this is chapter 15 review. So let's start with practice questions. So the question is a social researcher wishes to know if there is a relationship between gender and perspective on the death penalty. Data has been uh, collected on 221 persons and the results are displayed in the table below. Is there a evidence of a relationship between gender and perspective on the death penalty? So if you see, your rows include gender, male, female, and your columns represents favor and oppose. So first you have to state the null hypothesis. As we discussed, our null hypothesis would always be they are independent of one another, and our alternative would be they are dependent on one another. So if you see here, they are gender and perspective on the death penalty are independent, and then gender and perspective on the death penalty are dependent. So this is a right hypothesis and alternate, like null hypothesis and alternative hypothesis. So I will submit this. So the next thing is find the expected value for the number of males who favor the death penalty. So to solve these kind of problems, I will use calculation aid. The first thing is I will copy this data, and then I have to go to our Canvas course, business statistics course. I'll go to that and go to modules. In module 0 you will go to calculation aids and download chapter 15 calculation aids. So now which sheet to use? Usually if you see, you have this sheet, you have two worksheets. One is goodness of fit and the other is independence. So goodness of fit, you will be given probabilities, but in this case independence is what we are looking at, because our hypothesis was, are they dependent or independent of one another? That is what we are trying to determine. If you see, is there evidence that there is a relationship between gender and perspective on the death penalties? So what we are saying is there any relationship? Are they dependent on one another? So that is what we are trying to evaluate. So I will go to our independent sheet, and now I will copy the data which so this data I need to copy to our calculation aid. So I will copy somewhere here. So once you have this, the first thing is I will try to eliminate the total on the row and the columns. So whatever values you will enter only the without totals. So you are going to enter only these in our calculation aids. So the first thing is I will do this is, so again you will start from the corner, so you keep increasing based on the corner. So the first thing is 66, and then this is 46, and then we have this as 66 and this as 43. So if you see, this is male, this is female, and then I'm sorry, this one represents so usually each this here, maybe let me take this out. try to do. Okay, I don't think I can change those, but yeah, so this row represents favor, and this row represents oppose. So that's it's the same you are kind of plotting here in this actual value numbers. So your expected value numbers will be here. So these are your expected value numbers. So they are asking, the question is, find the expected value of number of males who favor over the death penalty. So they are asking male and favor. So this is actual value. So expected value should also be, so if you see, male and favor is this cell. So if you see, the expected value would also be same cell. So that is 66.89. That's how you are going to solve these problems. So I will kind of type in the expected value here and submit it. How about expected value for the number of male who oppose the death penalty? So if you see, male and oppose is this one. So that means our expected value would be this one. So I will copy that and paste it here. So once I submit that, yeah. So now find the value of the test statistics. So what is the test statistic value? So I go here, again the test statistic value. If I go down, this is the test statistic value, 0.0604. So I will copy that and paste it here. So that is my test statistic value. Find the degrees of the freedom with the test statistic. So what is the degree of freedom is what they are asking you. So again you will go the degree of freedom, if you see, that is what it is. So you copy the degree of freedom here, and that is 1, and then that will be your answer. And then find the critical value at alpha is equal to 0.005. So I need to type in alpha is equal to 0.005 here, and then the critical value would be 7.879. so that is I will copy that value. So let me highlight that. So that is our critical value. And then I will put the critical value, which is 7.879, and then make the decision to reject or fail to reject. So the decision would be fail to reject. So that is our decision, fail to reject. So the next question is, state the conclusion that when we fail to reject the null hypothesis, that means they are independent of one another. As you know, our null hypothesis is H null was in this case gender and perspective are independent. So gender and perspective are independent. And then alternative would be gender and perspective are dependent. So when we said fail to reject, that means this statement is true. They are independent. That means there is no relationship between mm, gender and perspective. So the conclusion would be there is significant evidence that are related. There is not significant, so there is, because they are independent, we don't have any evidence. There is not significant evidence that gender and perspective are related. So that would be your conclusion. Again, you can take the same, this is a different problem. So we can again do the same problem. So I will close this because I have written here some of this stuff. I will open a new calculation aid and copy this data. I will go to again chapter 15 calculation aids. I will download it. So I think this is the same gender favor oppose, same kind of problem. I will skip this. I will try to find a different problem and see. Yeah, so here I have a market researcher believes that brand perception of one of the companies may vary between different groups. After interviewing 307 people, persons, the following data was compiled. Can we conclude that the perception is dependent on age? So I have age in the rows and the perspective on, or the perception on the columns. So I have three different age groups and then three different perceptions. So as I said, our null hypothesis will be brand perception and age are independent. Always null hypothesis would be independent and alternative will be dependent. So this is our answer. So I will submit this. So the next one is find the expected value for participant whose age are 18 to 30 old and have a favorable perception. So they are asking us to calculate again the expected value. So I will copy this data and then paste it. Again, this is an independence problem because we are comparing two different independence. I think mostly in Hawk's learning, you shouldn't see much of goodness of fit. I think we removed those problems. We are only dealing with independence. So I suggest you to use independence. Goodness of fit, I think I tried to explain for understanding purpose, but we kind of don't, we are not testing on that. So independence, again, this is an independence problem. I will copy the data. So again, I'm going to remove this total here on the row and the column. I'm going to key in only these data sets. So now again I'm going to key in, this is 47, 42, 42, and then 63, 13, 11, 64, 12, and 13. So once you have this, these are your expected values. So currently they are asking expected value for 18 and 30 and have a favorable perception. So 1830 is this one and favorable is this one. So that means we will be using this cell to calculate the expected value. So that is 47 in this case, the first cell. So that will be this 74.24. So I will copy that and paste it here. How about expected value who are over 45 and have a favorable perception? So over 45, that is this one, and have a favorable perception again, that is this one. So maybe I will try to highlight with a different color, favorable and over 45. So you are looking for a value in this cell, which is the so I will go here and check that cell. So that would be my answer, 50.443. So find the value of test statistics. So what is the test statistic value? So I will go here again, go down. Test statistic value is 40.39. So I will copy that, and then the degrees of freedom. So in this case the degree of freedom is 4. So I will copy that. And then find the critical value at 0.025. So I have to type in 0.025 at in alpha place, 0.025. So the critical value would be 11.14. So that is this cell. So I will copy that, and make the decision to reject or fail to reject at 0.05 level of significance. So that is, you are rejecting your decision. So you will say reject H null, reject null hypothesis. So when you are rejecting null hypothesis, your null hypothesis is again, they are independent of one another. So when you say reject null hypothesis, your H null, so let me see, what is the conclusion. So your H null is age and perception are independent of one another, or perception and age are independent. That is your null hypothesis. And your alternative was the, perception and age are dependent. So here we said the decision is to reject the null hypothesis. That means this statement is false. So this statement is inherently true. So we are kind of saying that perception and age are dependent. So we are saying there is significant evidence that perception and age are related to one another. So that's how we are going to solve this problem. So again, we have different age. Again, this is the same kind of problem, but now you have different political bodies, and then you have different age groups. So let me solve this. I will try to solve this problem, and then that would be our end of this chi-square distribution problems for independence. So I will again download a new calculation aid, because I have written here. So I will go to our Canvas page. In calculation aids, I will do chapter 15, calculation aids. So you can use the same sheet again and again. I'm just downloading it because I'm writing on it. So I downloaded this. So the first question here is state the null hypothesis. So the question is, a political researcher wishes to know if political affiliation and age are related. He has collected data on 272 persons in 3 age categories. Is there evidence that age and political affiliation are related? So the first thing is null hypothesis. They are independent. They will be independent, and for alternative they will be dependent. So political affiliation and age are independent, and alternative will be political affiliation and age are dependent. So that will be your null hypothesis. And then they are asking you to calculate the expected value for the Democrats that are 18 to 31 years old. So I will copy this data again. And then this is again an independence problem, so I will paste it here. So again I'm going to remove this total row and total column, and I'm going to enter only the values. So this is 32. This is again I am copying these values. So this will be 86 and 43, 36. Oh sorry, this is wrong. 36, 15, 7, and then 32, 14, and then 7. So the question is, find the expected value for the number of Democrats that are 18 to 31 years old. So the first thing is, this is the Democrat column, and 18 to 31 years is this one. So 32, whatever value is in this cell will be expected value. So you are looking into these values for expected value. So the first cell values would be your expected value. So in this case your expected value is 59.19. So find the expected value for the number of Democrats that are 32 to 51 years old. So I'm going to go here, 32 to 51 years old, and then again I'm looking at the Democrats. So that would be whatever is there in this cell, so second cell. So I'm looking at this cell, so I will copy this and paste it here. Find the value of test statistics. So again I will go down and look for test statistic. Our test statistic is 48.45. so that is our test statistic value. So I will do copy and paste it here, and find the degrees of freedom with the associated with the test statistics. So I will go here again, I'm looking at degrees of freedom, so that will be 4. And then find the critical value at the 0.025 level. So I will go and type in here 0.025. so the critical value would be this one. So I will copy this and paste it here. So make the decision at 0.05 level. So that means the decision is to reject your null hypothesis. I will kind of say reject null hypothesis. So what is the conclusion? So when we reject your null hypothesis, that means we are saying uh, that the two variables are independent. That is false. So the alternative would be true. So if you see in this case, our null hypothesis, age and political affiliation are independent. So independent means they are unrelated. And then H alternative, age and political affiliation are related. So I'm saying reject, so that means I'm rejecting this, so this is true, so they are related. So I'm saying there is significant evidence that political affiliation and age are related. So I'll submit this. So this is how we will be solving problems on chi-square distribution, and this concludes my lecture on chapter 15. Thank you.